last example today is a piecewise defined function. So when x is greater than 1, you're going to use this function, and when x is less than or equal to 1, you're going to use this function. So as we set up our x and y values, we're going to have to try some values that are greater than 1. So maybe a 4, 3, 2, but when x is equal to 1, it's going to be this new function. Okay, and then we have 0, -1, -2. So when x is greater than 1, I'm going to plug in x here times -2. So this is going to be -8. 3 times -2 is -6. 2 times -2 is -4. 1 times -2, 1 is equal here, so I have to plug it into this function. So it's 1 plus 3, which is 4. And I'm going to just draw a line there so I have my barriers of my two different functions. 0 plus 3 is 3. -1 plus 3 is 2. -2 plus 3 is 1. So if you can see what's going on here, at 4, I have -8. Okay, so it's way down here. At 3, I have -6. And at 2, I have -4. Now this is going to be array, and it's set equal to here for right now. We'll just kind of leave it alone for a second. My other function at 1 is at 4, 0 is at 3, -1 is at 2, -2 is at 1, and it's going to be array going this way. Now obviously you want to use a ruler. I'm sorry, mine are a little bit off there. So then what we have to do is we have to figure out where we're going to have some open and closed circles here. Well, in this case, since it's equal to 1, my closed circle is going to be here. As it is greater than 1, it's going to get really, really close to -2. Really, really close. But it's never going to be exactly -2, because at exactly 1, it's going to flip up here to this other function. So I have to have an open circle on the -2 going down, and then I have my other function there. So this is an example of a piecewise defined function. You try the example in your notes. Here's a review. Step functions look like steps. Absolute value will always be a v, and piecewise will be two different rays going in different directions.